Imagine you're at this huge, sprawling party. I mean, thousands, maybe even millions of rooms. But as you wander through, almost all of them are just silent, empty. You find yourself standing there, looking around, and asking pretty simply, where is everybody?
That's such a great analogy. And it's a really profound question, isn't it? One that goes way beyond just a party and stretches right out into the cosmos itself.
Yeah.
That incredibly simple but incredibly deep question was famously asked by the physicist Enrico Fermi way back in 1950.
Wait, Fermi?
Yeah, he was just having a casual lunch talking with colleagues about, aliens, extraterrestrial life. And almost offhand, he just asks, where is everybody? And that question, seemingly out of nowhere, it kicked off one of the most enduring, most mind-bending mysteries in science, the Fermi Paradox.
And look, to really set the stage for this deep dive, you need to grapple with this fact. It's kind of jaw-dropping. There are more stars in the observable universe than there are grains of sand on all the beaches, on the entire planet Earth. Just try and picture that for a second. It's a number so huge, so overwhelming, it almost immediately makes you think, well, if the universe is that big, with so many potential homes, why does it seem so quiet? So empty?
That's exactly it. That's the heart of the paradox. Fermi's question just brilliantly sums up this striking, almost, unsettling contradiction.
Yeah.
On one side, you've got the sheer scale, this unimaginable vastness, plus everything we now understand about, the conditions needed for life. And all that strongly suggests the universe should be absolutely teeming with alien civilizations.
Statistically, it seems like it should be, right?
Statistically, mathematically, it feels almost inevitable. But then the other side is, despite decades of searching, all we get is this puzzling, almost deafening silence. There's just a profound lack of any solid evidence, any real contact. That right there is the Fermi Paradox.
And that silence, that profound quiet, that's exactly what we're going to unpack today. Our mission here in this deep dive is to really explore this cosmic puzzle. We'll get into why, statistically speaking, the universe should be buzzing with intelligent life. And then we'll take a journey through the most compelling and, sometimes pretty unsettling theories, trying to explain why it's so quiet out there. If you think of our galaxy like a huge, busy city, and every star is like a house, well, this deep dive is about trying to figure out, where are all the neighbors? Why don't we hear any noise? See any lights on?
Exactly. We'll look at a whole range of perspectives, from the scientific probabilities that suggest life should be pretty common to the various ideas, the hypotheses that try to tackle that really difficult question of why, if it should be common, we haven't found it yet.
It's going to be fascinating.
It's a journey that'll definitely challenge some assumptions, I think.
Yeah.
And hopefully it'll expand how you think about our place. Maybe our unique place, maybe not in this huge, mysterious universe.
It's a really compelling puzzle.
Okay.
So, let's get right into it. To even start thinking about the paradox, we first need to understand why we'd expect company at all.
Yeah.
What makes us think the universe should be full of life?
Right. You have to start with the canvas itself.
Our journey into the Fermi Paradox? Yeah, it absolutely has to begin by really trying to wrap our heads around the sheer cosmic scale we're dealing with. When we talk about the size of our galaxy and then everything beyond it, I mean, these aren't just big numbers. They're dimensions that are genuinely hard for us to even picture.
That's absolutely right. To try and put it in context, though, it still stretches the mind, our own galaxy, right? The Milky Way. It's estimated to have somewhere between, say, 100 billion and maybe 400 billion stars.
Billion, with a B.
With a B, yeah. And to visualize that, imagine if every single star was just one grain of sand. You'd end up with a pile of sand way bigger than Mount Everest.
Wow.
And that's just for our galaxy. Then you remember there are hundreds of billions of other galaxies out there in the observable universe. It's almost dizzying when you think about it.
And it gets even more interesting, doesn't it? Because it's not just the raw number of stars. All the recent work, especially from space missions like Kepler, the Kepler Space Telescope, that's fundamentally changed how we see things.
Oh, completely.
Before Kepler, maybe we thought, a bit arrogantly perhaps, that Earth was unique. Or at least, a super rare cosmic fluke. But Kepler's data just blew that idea away.
It really did. Kepler showed us pretty clearly that planets aren't rare at all. In fact, they seem to be incredibly common.
Everywhere, basically.
Its findings suggested that a really big chunk of stars, maybe even most of them, probably have planets orbiting them. And crucially, a lot of these planets are thought to be in what astronomers call the habitable zone.
The Goldilocks zone, right? Not too hot, not too cold.
Exactly. That specific distance from their star where the temperature is just right for liquid water to exist on the surface. And as far as we understand life, liquid water is just essential.
Absolutely key.
So you're not just talking about thousands or millions of potential worlds, you're talking potentially about billions of planets where conditions might be right for life just here in the Milky Way.
It's truly mind-boggling when you think about it like that. Billions of potential homes. So if so many planets exist where life could form, where maybe the basic conditions are actually pretty common,
Mm-hmm.
then why? Why haven't we heard anything? Not a single peep. Why does the cosmic neighborhood feel so deserted?
And that question leads us straight into one of the most famous kind of thought experiments in this field, the Drake equation,
Ah, yeah, the Drake equation.
devised by astronomer Frank Drake back in the 60s. Now, it's not meant to give us a precise final number of civilizations. It's more like a way to organize our thinking. It lays out the key factors that, if you could estimate them and multiply them together, could give you an idea of how many intelligent, communicative civilizations might exist right now in our galaxy.
It's a really useful tool, conceptually. It makes you think about all the different steps involved, right? Like the rate stars are forming. What fraction of those have planets?
Mm-hmm.
Then how many of those planets are in the habitable zone? What fraction of those actually develop life?
Then intelligence.
Right, then intelligence, then technology for communication, and finally, maybe the trickiest bit, how long does a civilization like that actually stick around?
Yeah, the lifespan factor's huge.
And here's the amazing part. Even if you plug in really, really conservative numbers for each step, say, only 1 in 1,000 habitable planets gets life, and only 1 in a million of those get smart enough to build radios, the final calculation. It still points to loads of civilizations.
That's the kicker. Even with pessimistic estimates, the Drake equation often spits out numbers suggesting our galaxy alone could host thousands, maybe even millions of intelligent civilizations capable of sending out signals. The sheer cumulative effect of all these probabilities, playing out across billions of stars over billions of years, it really points towards a universe that should be far from empty.
It feels like it should be buzzing.
It's not just wishful thinking, it's what the statistics, based on our current understanding, seem to suggest.
And that brings us to the last big piece of this why we expect company puzzle
Yeah.
time. It's not just the unbelievable number of potential places for life, it's also the almost unimaginable age of the universe.
Crucial point. Yeah.
We're talking something like 13.8 billion years since the Big Bang. Our own galaxy, the Milky Way, it's ancient. It's been around for billions and billions of years. That's just an incomprehensible amount of time for stuff to happen, for life to evolve, and maybe even spread.
Precisely. That enormous timescale means there's been ample time not just for life to pop up once, but maybe to emerge and reemerge over and over again across countless star systems. And for technologically advanced species, well, they should have had billions of years not just to develop, but maybe even to figure out interstellar travel and spread out, even across whole galaxies.
Even if travel is slow.
Think about it. Even if interstellar travel is painfully slow, say just 1% of the speed of light, a civilization could theoretically cross the entire Milky Way galaxy in, well, maybe a few million years.
A few million years. That's honestly just a blink of an eye in cosmic terms, isn't it?
It really is.
So if some civilization got started, say, just a million years before us, which is nothing, cosmically speaking, they'd have had more than enough time to spread out, set up shop across huge swaths of the galaxy. We should be seeing the signs, right? Where there are probes, their outposts, or those giant hypothetical structures like Dyson spheres built around stars to capture all their energy.
Things that would be hard to miss.
Exactly. Undeniable signs of super advanced tech. The fact that we just don't see any of that, despite the odds, despite the time, that's what makes the silence so incredibly weird, so profound.
The vast amount of time available for evolution and expansion is absolutely critical to the paradox. Given enough time, even slow expansion could lead to a galaxy filled with signs of life. Which brings us right back to that central nagging question. If the places, the probabilities, and the time are also favorable for life to not just emerge, but to spread, why the deep, seemingly unbroken silence?
Okay, so we've laid out a pretty strong case for why, statistically at least, we should expect the universe to be full of neighbors. But now we need to turn to the silence itself, the eerie quiet at the heart of the paradox. If civilizations are out there doing their thing, what kind of evidence should we actually be looking for? What would we expect to find?
Well, if alien civilizations were common and technologically advanced, our science predicts we should be able to see specific kinds of evidence. And we're not just talking about, fuzzy lights in the sky or strange anecdotes. We mean concrete, detectable signatures that, given the scale and time involved, we'd really anticipate finding.
Right. Like, the most obvious thing would be artificial signals, wouldn't it? Radio waves, maybe lasers beamed across space. We've been leaking radio waves out into the cosmos for over a century ourselves.
Exactly.
So a more advanced civilization might be doing the same, maybe even deliberately sending out beacons or messages. We're constantly listening with projects like SETI, trying to pick out anything artificial from all the natural cosmic noise, a pattern, something complex, anything that shouts, intelligence made this.
Indeed. And beyond just signals, our telescopes are getting powerful enough that we should theoretically be able to spot really large-scale technological artifacts. Think about engineering projects on a scale far beyond anything humans can currently manage.
Like those Dyson spheres you mentioned.
Potentially, yes. These huge, hypothetical structures built to completely enclose a star and capture all its energy. A star hidden inside one would look very strange, emitting mostly infrared radiation. Or maybe we'd see evidence of large-scale terraforming planets whose atmospheres or surfaces have been obviously artificially changed to suit alien life. These would be pretty unmistakable signs of advanced technology at work.
And then I suppose there's the most direct evidence imaginable. Actual physical visits, probes, artifacts left behind, maybe even encounters, whether it happened millions of years ago, leaving some trace, or even something happening now. Again, not just stories, but hard physical proof.
Proof?
These aren't just wild sci-fi ideas. These are the kinds of concrete, detectable things we logically expect to find if advanced civilizations are out there in large numbers, given all that time and space.
And this is where we hit the wall. The stark reality is, despite decades of dedicated searching with increasingly sophisticated instruments, we haven't found any conclusive evidence. None.
Nothing solid.
Organizations like SETI, the Search for Extraterrestrial Intelligence, they've been scanning the sky since the 1960s, using massive radio telescopes, pointing them at likely stars, doing wide surveys.
And the result?
Well, lots of interesting natural signals, but nothing that screams artificial origin. It's not just that we haven't found that smoking gun. We haven't even found, faint whispers or the cosmic equivalent of seeing distant city lights over the horizon. No persistent alien beacons, no weird megastructures that defy natural explanations, no confirmed alien probes turning up, just silence.
A profound, almost unsettling silence.
And this is where the paradox really hits home for you, the listener. Why? With all that cosmic real estate, all those billions of years for life to evolve, and all our dedicated efforts to listen, why does it seem like we're alone in this vast, silent cosmic ocean? Despite all our science, all our improving tech, the universe stays eerily, mysteriously quiet. And that continued lack of any definitive proof, despite our best efforts, that is the core mystery driving the Fermi Paradox.
Okay, so if the universe is so huge and full of potential, and we've been listening really hard for a long time, what are the leading ideas trying to explain this crazy silence? The proposed solutions tend to fall into three, fascinating and sometimes kind of chilling categories. Let's dig into the first one. The idea that maybe, just maybe, despite everything, we are basically alone.
Right. This first category tackles the paradox head-on by questioning its main assumption that intelligent life should be common. Instead, it suggests that the conditions needed for intelligent life to arise and thrive are actually far, far rarer than we might think. Like there's some kind of incredibly high bar, a cosmic bottleneck that life seldom manages to clear.
Okay, so the first big idea here is the rare earth hypothesis. This basically says that getting complex, intelligent life, not just some microbes, but things like us, requires this incredibly unlikely perfect storm of factors. A whole bunch of things have to be exactly right.
It's really illuminating when you break it down. The rare earth hypothesis points out just how many seemingly small details needed to align perfectly on Earth. It's not just being in the habitable zone. You need a stable star, like our sun, not too many violent flares that would sterilize the planet.
Right, a calm star.
You need a protective magnetic field, like Earth's, generated by its core, that shields us from harmful cosmic rays and stops the solar wind from stripping away our atmosphere and water. Without that shield, you end up with a barren rock like Mars, probably.
And there's more, right?
Maybe
Plate
okay.
tectonics.
Absolutely crucial, many scientists argue. We kind of take it for granted, but the movement of Earth's crustal plates does amazing things. It recycles elements, especially carbon, which helps regulate the climate over millions of years. It drives volcanic activity, releasing gases that build the atmosphere. It creates continents and diverse environments. Without it, you might just get a stagnant water world or a desert world with much less potential for complex life to evolve.
And our moon. I've heard that's important too.
A surprisingly big moon, like ours, is thought to be really important for stabilizing Earth's axial tilt. That gives us relatively stable seasons over long periods. Without the moon's gravitational tug, Earth's tilt might wobble chaotically, leading to extreme climate swings that could make it very hard for complex life to get a foothold and persist.
Wow. Okay.
And then there's the basic chemistry. You need the right mix of heavy elements, carbon, oxygen, nitrogen, etc., and of course, abundant liquid water. The rare Earth idea is essentially saying, maybe Earth isn't just special because it has life, but because the exact combination of all these astronomical, geological, and chemical factors needed for complex, intelligent life is just incredibly, incredibly improbable. We basically won the cosmic lottery.
It really makes you appreciate how many things had to go just right for us to be here talking about this.
Yeah.
If just one of those things was slightly off on another planet,
Mm-hmm.
maybe that's enough to prevent intelligence from ever emerging.
That's the core idea. Perhaps Earth is a genuine anomaly, an incredibly rare oasis for complex life in a mostly barren universe. All those billions of stars and planets might still only yield a tiny handful, maybe just one, world like ours, capable of supporting complex intelligence.
Okay, but even if you get a rare Earth, with all the perfect conditions lined up, stable star, magnetic field, moon, water, everything, there's still another massive hurdle, isn't there? Abiogenesis.
Yeah.
The actual origin of life itself.
That's potentially the biggest filter of all. Abiogenesis is the jump from non-living chemicals to the very first self-replicating, evolving life. We still don't fully understand how it happened here on Earth. We can create amino acids and other building blocks in labs, sure, but going from a soup of chemicals to something that's definitively alive, that's a monumental step.
Like catching lightning in a bottle, maybe.
Perhaps even rarer than that. It's not just about having the right ingredients, it's about the specific chemical pathways, the energy sources, the environmental conditions all coming together in precisely the right way at the right time for that first spark. Even if a planet is otherwise perfect for life, maybe the spontaneous generation of life itself is just an astronomical long shot, like a 1 in a trillion kind of event.
So maybe the universe is full of perfect planets that are just sterile. Because that initial start, that transition from non-life to life, just never happened. Maybe it only happened once here.
It's a definite possibility. If that first step is the great filter, the main bottleneck, then the universe could be filled with potentially habitable worlds that are just eternally lifeless, simply because abiogenesis is that hard.
And okay, let's push it further. Let's say you get past rare earth and abiogenesis. Life starts, it evolves. Is intelligence guaranteed then? The third idea in this we are alone category is that maybe intelligence itself is the rare thing.
This is a really important point because it pushes back against our natural tendency to see intelligence like ours as the sort of ultimate goal or peak of evolution.
Right. We assume evolution is always heading towards smarts.
But evolution doesn't really aim for anything except survival and reproduction in a given environment. Intelligence, especially the kind needed for technology and space travel, is just one possible survival strategy, and maybe not even a particularly common or successful one in the long run. Think about Earth's history.
Yeah.
Life's been here for billions of years, complex, multicellular life for over 500 million. But our kind of high-tech intelligence, that's only shown up in the last tiny fraction of Earth's history, with Homo sapiens and spaceflight, just in the last few decades.
Dinosaurs ruled for 160 million years, right?
Yeah.
Never built a telescope.
Exactly. Countless species have thrived, dominated ecosystems, and survived for millions of years without developing anything remotely like human-level intelligence or technology. Maybe the evolutionary path, even when it leads to complex animals, just very, very rarely results in creatures capable of or interested in building radios and spaceships.
So the galaxy could be teeming with life microbes, weird alien plants, maybe even complex creatures swimming in alien oceans, but still be silent to us, because intelligence capable of reaching out is just exceptionally rare, a fluke.
Precisely. It's a humbling thought. Our kind of intelligence might be less of a cosmic inevitability and more of a strange, perhaps unique evolutionary quirk that happened here on Earth. The specific pressures and opportunities that led to us might just not happen very often elsewhere.
Okay, that's category A. Some pretty profound reasons why we might genuinely be alone or close to it, but what if that's wrong? What if they are out there, maybe millions of them, buzzing with life and tech, but we just can't find them? That brings us to category B. We can't communicate or detect them.
Yeah, this set of explanations is really intriguing because it keeps the possibility of abundant life open. It shifts the focus from life being rare to us having limitations as observers, or maybe pointing to the behavior of the aliens themselves.
One of the first things that comes to mind here is just our own technology is probably pretty primitive on a cosmic scale, right? What if they're using communication methods we don't even recognize? We're listening mostly for radio waves, a technology that's only about a century old for us.
That's a huge point. A civilization just 1,000 years more advanced than us, let alone a million, might have moved way beyond radio. Maybe they use something like modulated neutrinos, which are incredibly hard to detect, or maybe gravity waves, or perhaps communication based on quantum entanglement, allowing for potentially instantaneous links across vast distances in ways we currently think are impossible for sending information.
So we're basically listening for smoke signals while they're using the subspace Ansible from Star Trek.
Kind of, yeah. We're listening for a specific type of phone call with our current tech. But they might be using an entirely different communication network, maybe something woven into the fabric of space-time itself that we haven't even conceived of. Our search methods could be like someone in the 18th century trying to detect Wi-Fi.
Yeah.
Beyond their paradigm.
That's really humbling. Our whole framework for looking might just be completely wrong, limited by our current physics and tech. We're projecting our own path onto the cosmos.
Exactly. And it raises that tantalizing possibility. What if the universe is noisy, full of complex signals, data streams, conversations, but it's all happening on channels we can't tune into, using physics we don't yet understand?
Okay, then there's a much darker idea in this category, one that's become famous in sci-fi, the Great Silence, or the Dark Forest theory.
Ah, yes. The dark forest. It's a chilling one. This theory suggests that civilizations deliberately avoid broadcasting their existence. They stay silent on purpose.
Why? Out of fear.
Essentially, yes. The theory paints the universe not as a friendly place for exploration, but as a dangerous, predatory environment. A dark forest full of hidden hunters. In this scenario, any civilization that reveals itself by sending out signals is like shouting your location in that dark forest. You immediately risk attracting the attention of older, more powerful, and potentially hostile civilizations.
So revealing yourself makes you a target.
It could. Why take the risk? A newly detected civilization might be seen as a future competitor for resources, or simply a potential threat to be eliminated preemptively. So the theory goes, the only rational survival strategy for any intelligent species that becomes aware of the potential danger is absolute silence. The quiet ones are the ones who survive. Everyone hides.
That completely flips the script on wanting to make contact, doesn't it?
Yeah.
It suggests the smartest thing to do is just listen and never ever transmit. Makes you rethink things like the Arecibo message we sent out.
It certainly does. If the dark forest scenario holds any truth, then our attempts at active SETI deliberately beaming messages out might be incredibly naive, even reckless, like a baby crying out in a jungle full of predators. It's a grim perspective on galactic sociology.
Okay, moving away from deliberate silence.
Mm-hmm.
What about just bad timing? Considering the immense age of the universe, maybe civilizations just don't last long enough to overlap with us.
This is another very strong possibility, the timescale mismatch. The universe is, nearly 14 billion years old? Our technological window where we can listen and potentially transmit is barely a century wide so far.
A tiny sliver of time.
Exactly. Now, imagine a typical advanced civilization exists for, say, 10,000 years before it collapses or transcends or whatever, and maybe its radio loud phase is only a few hundred years within that. The chances of two such civilizations existing close enough in space and overlapping in their brief communicative windows across billions of years of galactic history, well, those odds become incredibly small.
So the galaxy could have hosted thousands, millions of civilizations, but they just rose and fell, like fireflies blinking in the cosmic night, and we just happen to be in a dark patch.
It's a very plausible explanation for the silence. We might just be missing each other by cosmic moments. They might have been broadcasting 1,000,000 years ago, or they might start broadcasting 1,000,000 years from now. The sheer temporal vastness makes simultaneous existence incredibly tricky.
And even if they are out there right now, broadcasting, Space is big,
Hmm.
really big. Does distance itself just make it impossible? Signal degradation?
Yes, the tyranny of distance. This is a fundamental physics problem. Signals, like radio waves, spread out as they travel. Their energy follows the inverse square law, double the distance, and the signal strength drops to 1/4.
So they get faint fast.
Very fast.
Hmm.
A powerful signal sent from a star system, even a few hundred light years away, might be incredibly weak by the time it reaches us, potentially indistinguishable from the natural background static of the universe. We'd need unbelievably sensitive detectors to pick it up reliably.
And even if we did pick it up, communication is hardly practical, is it?
Not in any conversational sense, no. A message from, say, 50 light years away takes 50 years to get here. A reply takes another 50 years to get back. That's a century for one round trip. You can't have a dialogue. You can only exchange monologues across generations. The vast distances impose immense time delays that make real-time interaction impossible with known physics.
It's like a cosmic game of telephone played over centuries, with the message getting fainter and fainter with every light year. Maybe the signals are out there, but they're just too weak, too old, or the conversation takes too long for us to notice.
It's entirely possible. The universe itself, through its sheer scale and the laws of physics governing signal propagation, might be acting as a natural silencer, regardless of how many civilizations are actually trying to communicate. It's not necessarily deliberate silence, it's just the inherent difficulty of shouting across the cosmos.
Okay, so we've covered the idea that maybe we're rare, or maybe we just can't connect. Now, for Category C, they exist, they're advanced, but for various reasons, they choose not to visit us or make themselves known.
Right. This category delves into some really fascinating possibilities involving alien motivations, ethics, or maybe just practicalities we haven't considered. It assumes they could be here or at least make contact, but they don't. Why not?
Well, one pretty dark explanation that often comes up is self-destruction.
Hmm.
Maybe advanced civilizations just don't make it. They invent something powerful like nukes or runaway AI, or they trash their planet and poof, they're gone before they can really start exploring the galaxy.
This is a really sobering thought, and one that resonates strongly with our own current challenges, doesn't it? The idea is that maybe technological advancement inevitably comes with existential risks. A civilization develops the power to reshape its world, travel between planets, harness incredible energy, but it also develops the power to destroy itself, perhaps through war, environmental collapse, uncontrolled technology like nanotech plagues, or unfriendly superintelligence.
The great filter concept again, maybe, but specifically tied to technology.
Exactly. Perhaps there's a kind of universal tendency for a civilization's technological power to outpace its wisdom or its ability to manage that power collectively. Think about our own close calls, our ongoing struggles with climate change, nuclear proliferation, AI ethics. Could these be typical hurdles that most civilizations face and perhaps most fail to overcome?
It's like looking in a dark mirror, isn't it? Seeing our own potential future reflected in the silence. Maybe every time a species gets smart enough to build spaceships, it also gets smart enough to wipe itself out shortly after.
If that's the case, the silence we observe isn't emptiness, but rather the sound of countless past civilizations failing their final exam. A cosmic graveyard, echoing with warnings about the dangers of unchecked technological growth. It suggests a recurring pattern. Rise, develop tech, collapse. Rinse and repeat across the galaxy.
Okay, that's pretty grim. What about a more, well, maybe more intriguing idea? The non-interference idea, sometimes called the zoo hypothesis.
The zoo hypothesis. Yes, this one is fascinating. It suggests that aliens are out there, they know about us, they might even be observing us, but they deliberately avoid making contact. They choose to leave us undisturbed, like curators of a galactic zoo or wildlife preserve.
So we're basically an exhibit, or maybe like an uncontacted tribe they don't want to interfere with.
Precisely. Imagine advanced anthropologists studying a remote tribe on Earth they might observe from a distance, learn about the culture, but refrain from landing a helicopter in the village square and handing out smartphones because that would irrevocably alter the society they're studying. The zoo hypothesis scales that idea up to the cosmic level.
So there could be, like, a galactic federation out there with rules,
Yeah.
a prime directive, like in Star Trek.
That's the implication. It suggests a level of coordination, ethical consideration, and perhaps patience among advanced civilizations that is, frankly, hard for us to imagine. They might have rules about contacting developing civilizations like ours, perhaps waiting until we reach a certain technological or ethical threshold before initiating contact. Or maybe they just find us interesting to watch from afar without any intention of ever interfering.
Wow. It means they could be watching us right now. And we're completely oblivious. It's kind of humbling, but also a bit creepy. Like we're cosmic reality TV.
It explains the lack of contact without requiring life to be rare or technology to prevent it. It's a choice on their part. And it raises huge questions for us. What level of development will qualify us for contact? And would we even want it, knowing we'd been observed like animals in a zoo for potentially millennia?
Okay, one last idea in this category, maybe the most mundane but practical one. Is interstellar travel just too hard? Too far, too expensive, even for super advanced aliens?
This brings us back down to the harsh realities of physics and engineering. Even if you have incredibly advanced technology, the sheer distances between stars are daunting. Getting from one star system to the next requires unimaginable amounts of energy.
More energy than a civilization might be willing to spend.
Possibly. Think about the resources required. Building fleets of interstellar ships, powering them across light years, sustaining crews or complex AI for centuries or millennia. It might simply be too resource-intensive, too slow, or too impractical to be worthwhile for most civilizations, even highly advanced ones.
Even if they have something like warp drive, which is pure speculation for us anyway.
Even then, the energy costs predicted by theoretical models are often astronomical. And maybe there are fundamental physical limitations we don't understand that make rapid interstellar travel truly impossible or prohibitively dangerous. Perhaps exploring and colonizing one's own solar system is challenging enough, and the leap to the stars is a barrier few, if any, bother to cross because the return on investment just isn't there.
So they might just stay home, content to manage their own star system, perhaps virtually exploring the galaxy instead of physically.
It's a plausible scenario. Why spend millennia traveling to another star if you can build vast virtual worlds or achieve longevity or focus your resources on other grand projects within your own system? Interstellar colonization might just be a romantic notion that doesn't make practical sense for most long-lived, stable civilizations. The sheer cost, time, and difficulty might act as a powerful deterrent.
Okay, this next concept really ties a lot of these ideas together, and it's where things get really, really interesting, maybe even a bit scary for us. The Great Filter.
Ah, yes, the Great Filter. It's a powerful and potentially quite sobering concept introduced to really grapple with the implications of the Fermi Paradox.
So what is it exactly?
The basic idea is that somewhere along the incredibly long journey from the very beginning of life, say, simple microbes, to becoming a civilization capable of colonizing other stars, there must be at least one step that is incredibly difficult, a filter or a bottleneck that is so hard to get through that almost no life ever manages it.
A massive hurdle somewhere on the evolutionary or technological path.
Exactly. A point of immense difficulty, an obstacle so challenging that it effectively prevents the vast majority of potential life from ever reaching a stage where we might detect it, like becoming a galaxy-spanning super civilization. It explains the silence by saying, something stops them.
And the really crucial, maybe terrifying question is, where is that filter? Is it something in our distant past that we've already overcome, or is it still waiting for us up ahead in our future?
That's the crux of it. Let's take the first possibility. The filter is behind us.
What would that mean?
It would mean that one of the steps we've already passed was the incredibly difficult one. Maybe it was abiogenesis, the origin of life itself from non-living matter. Perhaps that spark is just extraordinarily rare.
So getting life started at all was the filter.
Could be. Or maybe it was the jump from simple prokaryotic cells to more complex eukaryotic cells, which took billions of years on Earth. Or perhaps the development of multicellularity, or complex tool-using intelligence like ours. If any of those past steps were the great filter, then we are incredibly, exceptionally lucky.
We made it through.
We made it through the near impossible bottleneck. It would mean that complex, intelligent life like us is genuinely rare in the universe. We are survivors of a cosmic lottery, maybe even unique in our galaxy. In this scenario, the silence is expected, because we're one of the very few, perhaps the only ones, who passed the test.
That's actually kind of a hopeful thought in a strange way. It makes us special, precious even.
It does lend a certain significance to our existence, yes. But then there's the other possibility, the one that tends to cause more anxiety.
The filter is ahead of us.
Exactly. This is the more chilling prospect. It suggests that the really hard part isn't in the past, but is yet to come. It implies that there's some inevitable challenge or catastrophe that routinely prevents civilizations that reach roughly our level of technological development from going much further, from becoming truly interstellar.
So something usually happens to civilizations like ours.
That's the implication. It suggests that maybe advanced technology itself creates unavoidable existential risks. Perhaps almost all civilizations that develop nuclear weapons, or powerful artificial intelligence, or advanced biotechnology, or face global environmental crises due to industrialization, perhaps they almost always fail to navigate those challenges successfully.
And that failure is the great filter.
It could be. This is where it gets really personal, doesn't it? What if the challenges we are facing right now, climate change, the potential dangers of AI, the risk of global conflict, what if these aren't just problems for us, but are manifestations of the great filter that has silenced countless civilizations before us? Are we currently navigating the very bottleneck that determines whether a species makes it or not?
That's a profoundly sobering thought. It means our future isn't guaranteed at all. We might be right at the doorstep of the very thing that explains the cosmic silence.
If the filter is ahead, our continued existence, our potential to become a multiplanetary or even interstellar species, hinges entirely on us successfully overcoming this unknown but potentially universal and incredibly difficult challenge. It forces us to ask, are we special because we're destined to pass it, or are we simply approaching the same barrier that has stopped everyone else? Our future suddenly looks much more precarious.
Wow. Okay. Despite that potentially terrifying prospect and all the silence, humanity being humanity hasn't just thrown up its hands and given up, right? We're still looking. The search for answers is ongoing.
Oh, absolutely. If anything, our efforts are becoming more sophisticated, more ambitious, and broader in scope than ever before. The quest to figure out if we're alone is still a major driving force in science.
And the most famous effort is still SETI, right? The search for extraterrestrial intelligence.
Yes, SETI in its various forms continues to be a cornerstone. For decades, astronomers have used radio telescopes to systematically listen for narrowband signals, artificial patterns that would stand out from the natural cosmic noise. It's a patient, persistent effort, basically eavesdropping on the universe, hoping to overhear something deliberate.
And now there are even bigger, more powerful projects involved.
Definitely. Initiatives like Breakthrough Listen, funded privately, represent a massive increase in scale and capability. They're using some of the world's best telescopes, radio telescopes like Green Bank, optical telescopes as well, to survey 1 million nearby stars and the centers of 100 nearby galaxies across a huge range of frequencies. It's the most comprehensive search ever undertaken.
So we're casting a much wider net and listening more intently than before.
Exactly, pushing the boundaries of detection technology. And alongside listening for signals, we're also getting much better at finding and characterizing planets around other stars, exoplanets.
Right, finding potential homes.
And going beyond just finding them. Telescopes like the James Webb Space Telescope are now capable of analyzing the atmospheres of some of these exoplanets. We're looking for biosignatures, chemical clues in the atmosphere, like the presence of oxygen and methane together, or other combinations of gases that, on Earth, are primarily produced by life.
So not necessarily looking for intelligence, but just for life itself.
Precisely. Finding robust evidence of any kind of life, even simple microbes, on an exoplanet would be revolutionary. It would tell us that life isn't unique to Earth, fundamentally changing the odds in the Drake equation, and maybe suggesting the abiogenesis filter isn't insurmountable.
And we're also looking closer to home, aren't we? Within our own solar system.
Yes, astrobiology missions are a key part of the search, too. NASA's Mars rovers, like Perseverance, are explicitly looking for signs of past microbial life in Martian rocks and soil. Samples are being collected for eventual return to Earth for incredibly detailed analysis.
And places like Europa, Jupiter's moon.
Europa and Saturn's moon Enceladus II are hugely exciting targets because they appear to have vast oceans of liquid water hidden beneath icy shells, potentially warmed by tidal forces. Future missions like Europa Clipper aim to investigate these ocean worlds, looking for conditions suitable for life, and maybe even direct evidence of it in plumes erupting from their surfaces. Finding life, even simple life, within our own solar system would be absolutely paradigm-shifting.
It really shows how multi-pronged the search is. Now listening for signals, studying distant atmospheres, drilling into Mars, planning missions to ocean moons, it's an incredible testament to our drive to find answers.
It truly is. The fundamental question, are we alone, continues to inspire some of humanity's most ambitious and exciting scientific endeavors. We haven't found the answer yet, but we are definitely looking harder and smarter than ever before.
So after journeying through the vastness, the silence, the theories, the filters, where does that leave us? What does it all mean? This whole Fermi Paradox thing, it really pushes our thinking, stretches our imagination like, almost nothing else.
It really does. And the implications, depending on what the eventual answer might be, are genuinely profound and kind of run in two opposite directions.
How so?
Well, on the one hand, if it turns out that, despite everything, we are truly alone, or at least incredibly rare, maybe the only technological intelligence in our galaxy, that places an almost unbelievable value on Earth and on life here.
Makes this incredibly precious.
Incredibly. It makes our planet this unique, fragile oasis in a vast, silent desert, and it puts an immense responsibility on us as potentially the sole bearers of consciousness, curiosity, and technology in this corner of the cosmos to survive, to steward our world, maybe even to eventually spread life beyond Earth. It makes our existence deeply significant.
But then what's the other side of the coin? If life is common, as the numbers seem to suggest, but something stops it from becoming visible if the silence is due to filters or dangers.
That's the more cautionary implication. If life starts easily, but advanced civilizations inevitably run into problems, self-destruction, technological traps, the dark forest scenario, then the silence is a warning sign for us. It suggests that the path ahead for any technological species is incredibly perilous. It forces us to look very carefully at our own trajectory, our own global challenges, and wonder if we're just repeating a pattern that has played out tragically countless times before.
So either we're almost miraculously unique and bear a huge responsibility, or we're potentially following a well-trodden path towards a universal danger. That's quite the dichotomy.
It is, and the paradox powerfully reminds us of a key scientific principle. Absence of evidence is not evidence of absence. Just because we haven't found aliens yet doesn't definitively prove they aren't out there.
Our search has only just begun, really.
Exactly. By cosmic standards, we've been looking for a mere instant with limited tools over a tiny fraction of the sky. The universe is vastly older and larger than our search parameters. We might not have looked in the right places, or listened for the right kinds of signals, or waited long enough. What we haven't found yet simply means we haven't found it yet.
Leaves the door open, keeps the mystery alive.
It encourages continued scientific curiosity, exploration, and open-mindedness. The answer, whatever it is, will be profound.
And that really leaves us with one final kind of provocative thought to chew on, something to ponder next time you look up at the stars. If the universe is actually teeming with intelligent life, but they're all staying quiet, perhaps out of caution, maybe adhering to that dark forest idea, what would it actually mean for humanity to be the ones to break that cosmic silence, to deliberately announce our presence to the galaxy? Would that be an incredible act of courage, a bold step forward for intelligent life, or would it be an act of profound, perhaps catastrophic folly?